Matter is the stuff that makes up the universe. Everything that takes up space and has mass is matter. All matter is made up of atoms, which are in turn made up of protons, neutrons and electrons. Atoms come together to form molecules, which are the building blocks for all types of matter, according to Washington State University. Both atoms and molecules are held together by a form of potential energy called chemical energy. Unlike kinetic energy, which is the energy of an object in motion, potential energy is the energy stored in an object. There are four natural states of matter: solids, liquids, gases and plasma. Solids. In a solid, particles are packed tightly together so they don't move much. The electrons of each atom are constantly in motion, so the atoms have a small vibration, but they are fixed in their position. Because of this, particles in a solid have very low kinetic energy. Solids have a definite shape, as well as mass and volume, and do not conform to the shape of the container in which they are placed. Solids also have a high density, meaning that the particles are tightly packed together. Liquids. In a liquid, the particles are more loosely packed than in a solid and are able to flow around each other, giving the liquid an indefinite shape. Therefore, the liquid will conform to the shape of its container. Much like solids, liquids, most of which have a lower density than solids, are incredibly difficult to compress. Gases. In a gas, the particles have a great deal of space between them and have high kinetic energy. A gas has no definite shape or volume. If unconfined, the particles of a gas will spread out indefinitely. If confined, the gas will expand to fill its container. When a gas is put under pressure by reducing the volume of the container, the space between particles is reduced and the gas is compressed. Plasma. Plasma is not a common state of matter here on Earth, but it may be the most common state of matter in the universe, according to the Jefferson Laboratory. Stars are essentially superheated balls of plasma. Plasma consists of highly charged particles with extremely high kinetic energy. The noble gases, helium, neon, argon, krypton, xenon and radon, are often used to make glowing signs by using electricity to ionize them to the plasma state. Modern states of matters. Supercritical fluid. At sufficiently high temperatures and pressures, the distinction between liquid and gas disappears. Degenerate matter. Matter under very high pressure, supported by the Pauli exclusion principle. Electron degenerate matter. It is found inside white dwarf stars. Electrons remain bound to atoms, but are able to transfer to adjacent atoms. Neutron degenerate matter. It is found in neutron stars. Vast gravitational pressure compresses atoms so strongly that the electrons are forced to combine with protons via inverse beta decay, resulting in a super-dense conglomeration of neutrons. Normally free neutrons outside an atomic nucleus will decay with a half-life of just under 15 minutes, but in a neutron star, as in the nucleus of an atom, other effects stabilize the neutrons. Strange matter. A type of quark matter that may exist inside some neutron stars close to the Tolman-Oppenheimer-Volkoff limit, approximately 2 to 3 solar masses, may be stable at lower energy states once formed. Quantum spin Hall state. A theoretical phase that may pave the way for the development of electronic devices that dissipate less energy and generate less heat. This is a derivation of the quantum Hall state of matter. Bose-Einstein condensate. A phase in which a large number of bosons all inhabit the same quantum state, in effect becoming one single wave particle. This is a low-energy phase that can only be formed in laboratory conditions and very cold temperatures. It must be close to 0 Kelvin or absolute zero. Satyendra Nath Bose and Albert Einstein predicted the existence of such a state in the 1920s, but it was not observed until 1995 by Eric Cornell and Carl Wyman. Fermionic condensate. Similar to the Bose-Einstein condensate but composed of fermions, also known as Fermi-Dirac condensate. The Pauli exclusion principle prevents fermions from entering the same quantum state, but a pair of fermions can behave like a boson, and multiple such pairs can then enter the same quantum state without restriction. Superconductivity. It is a phenomenon of exactly zero electrical resistance and expulsion of magnetic fields occurring in certain materials when cooled below a characteristic critical temperature. Superconductivity is the ground state of many elemental metals. Superfluid. A phase achieved by a few cryogenic liquids at extreme temperature at which they become able to flow without friction. A superfluid can flow up the side of an open container and down the outside. Placing a superfluid in a spinning container will result in quantized vortices. Supersolid. Similar to a superfluid, a supersolid can move without friction but retains a rigid shape.